Good day. Good day, everyone. Good day. Let's just wait for some minutes before we start. Let's go. Wait for some more minutes for more people to join. Maybe there's some on YouTube that are going to stream. All right, so um, we'll be talking on we'll be continuing forward stop last when we deploy TensorFlow deep learning model, right, using Docker. And what we do is that we'll build on top of that to work on Kubernetes. Okay, so um, let's let me just wait for a few minutes while I share my screen. Okay, so I hope my screen is visible. Um, so this is where we are. This is where I dropped off. Um, it's when I built the model, I trained the model. I then used the Docker image for TensorFlow 7. What's that? So I used the image for TensorFlow 7. Started again. Sorry for the delay. TensorFlow 7, Docker Hub. Okay, so that's why I used the TensorFlow image and I built a Docker file. Wait. So let's go from here. Trying to resolve something on my PC. I don't know why it's lagging. Doesn't make any sense for it to be lagging. So yeah, I think it's back now better. I almost like to use Firefox. Chrome is something else. All right. So today we're just going to be use the Docker image to create a cluster on a local. We're going to create a cluster on a local, and we're going to use kind for that, right? So let me let me show us how we can install kind. We use Minikube in for our development, but we can also use kind. Kind is it's just the same thing as Minikube for local deployments. it will resume itself. So for those of us that don't have kind, I'm specifying kind because in the next session we'll most likely use kind to or next week most likely use kind to set up KServe, right? KServe pipeline and stuff like that. So that's why I'm just saying we should install kind. So if you are using Mac or Windows or Linux, you can just go to kind and you will see a way to set up on Linux or Mac and Windows, right? If you have Go in your local, you can also just run Go install if you have Go in your local installed. All right, so let's get going. So what I'm going to do is that remember that I built an image. I have an image that I built, right? And so if I want to set up, use that image to build a a Kubernetes cluster, I have to have access to it somehow, right? So there are there are two ways to go about this, right? You can load the image from your local into your cluster, right? And the way to do that is just run kind load docker image, the name of the image, right? So let me say docker image ls. That's the command. So it's going to list a whole lot of images on my local. I have Tensor TF7 classifier running. I have Mongo Express, Mongo. I have MySQL. I also have Minikube. Minikube is also like a Docker image, kind also the Docker image. I have RabbitMQ and I have Hello World. That most likely came with a cluster. So now, since this Docker image is here, right? The cluster doesn't have access to it, right? So we can always like do kind. I think they are let me just use help to remember. So kind, yeah. So we can always use kind load images, right? So that's going to load the image into a node, right? Into your node. All right, but standard procedure is when you are building your deployment YAML file, you specify an image, right? Image. You specify an image, and most likely you have the image is already hosted on Docker Hub, right? So what Kubernetes does is that is this image firstly in our local? If it's not on our local, it goes to Docker Hub to download it from Docker Hub and load it into our cluster, right? So that's what I'm doing here. You could have like gotten that image and loaded it into Docker Hub, right? That would be also a nice practice, right? To how to load an image into or save an image to Docker Hub, right? Most likely just going to have to you most likely have to create an account and follow these steps to load the image into to Docker Hub. So yeah, you have to log in, then you have to select Docker image and tag the Docker image with a name, that is then push into your repository, giving it a name, almost like GitHub, right? It's almost like GitHub, where you have to put in credentials, then you now do Git, almost like Git pull, Git push. You can do Docker pull, Docker push, right? But before you push the image, you almost like have to give it a tag. But we have already given out the tag, so I could just do Docker push that image into my username and with the repo I want to save it into, right? So that's that. That's how to do that. It can be an assignment for you. Right, so to continue from where this is going to be a short tutorial because I'm leaving some part for next session, right? So what I'm going to do is now I'm not going to do kind load Docker image into my kind cluster, right? So you're going to load the image into the node, the Docker image, TF7 classifier into the node. So I've already done this before. So it's going to now like show that the image is there. So I want to find the the command I can use to check the images in my kind cluster. Uh, okay, let me see. If I can't do that, I'll just move on to Let me see. Get cluster. Maybe I'm going to search on that and show us later in the next session. So, all right, now, so since we have the image in our cluster, what we can do is to build a deployment, create a deployment file, right? And last session, I showed us how to create a deployment YAML file, right? You can just, if you have VS Code, you could just type deployment and it's going to give you like a starter code where you can just impute, right, the metadata name, the labels you want to give to the pod, right, the name of the label for the pod and container names and image name, the limit resources you want, and also the port number, right? So let me recap. So this is going to be a kind deployment, and the name of this deployment is going to be TF7 classifier, right? So the pods that will be in that deployment are going to have the label TF7 classifier, right? So this is how the deployment is going to know which pod should be in the deployment, how many, like which pods are in the deployment, right? So remember that the deployment is a group of pods. So now the template is where you describe your pod, right? This is where you describe what you want to be in your pod. And the first thing we're going to do is that for a pod that's going to be created with this manifest file, right? It's going to have a label app TF7 classifier, right? So it's the label we're going to give the pod. And so it's for specifications for the pod, right? For each pod, the containers we're going to run in that pod is going to be TF7. We're going to give it the name TF7 classifier, and the image is going to be TF7 classifier version 01, right? Since we have already searched for the images we have and we loaded it. So we're going to use TF7 and this is a tag, right? So there are different kind of tags. You can have latest, most likely when you get it from Docker Hub. You can have like version name as a tag, V or just number. So your tag could be arbitrary anything, just for you to determine like what do you want to give it. It's most likely an organization issue or a personal issue, personal preference. So whatever you want to do, you can give it, you can whatever tag you want to give, you can give it, right? So we give ours that version 01, V01. And so we're going to specify the resources we want and the limit, right? We shouldn't go more than this, the maximum number of compute resources we want for a particular pod, right? So we want the memory, most likely, yeah, the RAM to be 128 megabytes, right? That's sufficient for loading the the module, because it's going to have the model, right? It's going to load the model into the RAM, and so the CPU is most likely for processing, right? For quick processing. How much CPU speed or CPU cores do you want to let that port to access, right? So we're also going to specify a port, and if you remember from the Docker image for TensorFlow 7 Docker. Uh, so for from Docker Hub, we can get access to what ports should we use. And remember, I told you that there are two ports open on TensorFlow 7, right? You can use two request types or endpoint type, right? You can always use the gRPC and the REST API, and you specify environment name for the environment variables for the model name and whatnot, right? So remember, we were working with port 8501 because we're using JSON to send requests, right? So we are going to specify the port number for this port to be 8501. This is what we're going to expose, the port number we're exposing for the ports, right? So I could just run kubectl. No, let me just also remember, if you want, it's best practice for you to um, connect to a deployment or a pod from using a service, right? So you want to use a service to make requests to a pod because, like I said in last class, a deployment or a pod can go down can go down depending on whatever network, depending on your nodes, right? Your node could have some issues, right? Some RAM issues and whatnot, and that will make your pod go down. And if you make um request trace to your pod, right, it's most likely going to give you an issue because once the pod is down, it's going to create a new pod with a new IP address, and um, you don't know what IP address that is. It's going to give you the unique IP address and specification. So you're going to know that you have to create a service, right? It's going to help you connect to your pod, and you can give the name of the service TF7/SVC. And so how is it going to know what pods to route the service traffic to? So any pod that has a label app TF7 classifier, the service is going to send traffic to those pods specifically. So it's going to know how to, it's going to have maybe a list. It's most likely a list, right? List of endpoints registered to it that have this TF7 classifier in. So maybe every minute is refreshing, every hour is refreshing, depending on configuration settings to check if what pods have this, whether some are down, some are up. So that's Kubernetes in like in-depth Kubernetes are if you want to know, you most likely have to like research more on Kubernetes. So we're mapping the port 80 of our service, right? So if you want to connect to the service, you're going to use port 80, right? And so when you send traffic to port 80, it's going to send that request. Your service most likely acts like a load balancer, right? It's kind of we direct requests based on pods available, right? And so it's going to send the request to a pod of its choice, right? The target port 8501. So you don't really need to know how it's going to do that. You just know that it's going to route the traffic to a pod in the endpoint list. So since I've explained the service and deployment, you could just run kubectl apply, right? So there are a lot of commands you could use in kubectl. There are a lot of them, and I don't know why there are so many. And I just use apply, expose, maybe explain, delete. I don't know. Most of these are specific use cases, right? When you actually creating a real world cluster, that's when you most likely use commands like this, right, to manage your Kubernetes cluster. So yeah, now what I'm going to do is just do kubectl apply kube config. Most likely that's where my configuration is saved. Kube config folder, right? Kube config, and I'm just going to let it run for the both manifest file, deployment, and service. So it's going to know that there are two um, kinds of services to create, right? So when we do that, we can always check has it loaded the image successfully. We can do kubectl get pods, right? I'm just doing a recap of all of the commands we use. You can always do kubectl describe this for. Oh yeah, we didn't specify what kind of service that is, so we can just say pod. So we can see that um yeah, so this is the IP address for this pod and or this deployment. Yeah, anyone for this pod. And we can see how it started, right? Scheduled, right? The container image is present, and like I said, it first starts from your local. Then from your local, it looks for if it doesn't find the image, it's going to go to Docker Hub to download it or whatever you specify to it because there are different image repositories out there. I think yeah, there are a lot of them. I think even the cloud services have theirs too, so there are a lot. So it's going to now create and see that it started all in 1 second. So it depends if it was going to download, it was like going to be longer because it had to download it. So yeah, we have the uh, yeah, we see that it's already in event loop. Remember when we created it with Docker image, it's going to we're seeing these what's it called logs, right? These are logs, right? You can use to debug your image or your pod, right? So You see that it's already running entering an event loop, no errors. We can now do kubectl. We see TF7 service up, and we can also describe it, right? So remember I told you about endpoints. Endpoints, like how does um the Kubernetes service know what pods to send traffic to? Okay, let's see. So now we see something called endpoints, right? These are all this is selector. How does it know which port to send traffic to? Type cluster IP. Remember, there's node ports and a load balancer. So the port is working with it, port 80. It has an IP address. And we see endpoints here. So the endpoints could be this is just because there's just one port. If there were three ports, you most likely have a list here with different IP address and port numbers, right? So if you remember this IP address, the same IP address for this port 1024 2440.6, right? So that's how the service knows what port to send traffic to, right? So now we have everything running. We can make a request to, we have something to do, right? So now the next thing we need to do is I don't know if we all know what port forwarding is, right? If you've worked with Jupyter notebooks, you know that after creating a Jupyter notebook or running the command Jupyter notebook, it's something called port forwarding, right? So it opens that port for you to send requests through a browser or anywhere, right? Because why we're doing this now is because we don't have, is a cluster IP type, right? It doesn't have an external IP where we can access over the internet, right? We don't have it's not hosted on the cloud where we have it's accessible to the internet and maybe a load balancer and stuff like that. So because of that, if you want to make requests to it, you can't make requests to it just like that, right? You have to open up the pod. You have to open up the pod to traffic, right? So to do that, there's a command called kubectl port forward. It's so like name subject, it's going to give you access to a particular pod, right? So we're going to port forward the service, TensorFlow service. Yeah, and just copy that, right? And so we have to specify something. What ports are you mapping it to, right? Remember, a pod is like a computer on its own. The service is also like a host on its own, right? So what you're going to do, what you're doing is like you're connecting to pods together, like you're just mapping them together, connecting them. Maybe if you can visualize a Ethernet cable, right? You're just connecting two things together. And so I'm going to map up port 8080 of my local to port 80 of that service, right? Remember, port 80 is where the service is running, it's open on, right? So we're connecting our local PC port 8080. Hopefully nothing is running on port 8080. It could be anything from 1 to 30,000, right? It could be anything, like we put 10. Just make sure you don't put any port that is usable, that's running now, because it's going to give you an issue. Most likely port 22, port 80 on my local is most likely taken, right? Maybe port 443, all these familiar ports, port 21 for FTP, SSH is port 2022. And so you don't want to put those ports because it's going to throw an error for you. Most likely want to put an open port, right? There's not, and no service is using it right now. So that's that, right? So I hope we understood that. So if I run that, we see that its port is open for connections, right? So it's mapping my local host port 8080. And you remember, there's a service in between them. So it just went straight to the port of the pod. If you can, it's just like it's telling you whatever connection you're sending to this is going to be sent to a pod 8501. Right. So that's that. So I'm ready to make requests now to that endpoint. Okay. Don't know what's running on my PC now that. So remember, for the predictions, we are loading data, right? We are reshaping them, putting them in the right format, right? We are doing all the pixel normalizations, and the most important part for you all is the URL. Remember to make a request to TensorFlow serving, right? It has to be in its format, HTTP, localhost 8501. You're going to give it a version number v1, models, right? Remember when we were talking about the configuration of TensorFlow 7, I need to update my Zoom. Looks like this Zoom is giving me this issue. So it has to be, it defaults to model, right? So any model you're saving has to be in a model folder, something like that. So if you want to make requests, you have to go through the model folder. And when when you want to make a request to a model, right, to give it the model name and you put colon predict, right? There are a lot of other actions you could do, right? And I would love to show us, but it's going to take some time. My PC is, I don't know why Zoom is doing this to me. So if you remember, REST APIs work with JSON. So we're going to, JSON and dictionaries are almost alike, right? So, but JSONs actually have double quotations, that be double quotes, right? Instead of single quotes. Remember, in a dictionary, you could have single quotes, you could have double quotes. But if you want to put it to the format of a JSON, you most likely just call JSON or dumps. JSON is a module on in Python. So you can just write JSON.dumps. And what this command is going to do is that it's going to convert that object to a JSON formatted string, right? So, and we put our labels, right? So in our case, they are numeric, but in your own case, you most likely have a user interface and that accepts images straight, right? So whatever you get from that image, you do the pre-processing, right? And you send it to the URL in your case, right? That will most likely be what the machine learning engineer, MLOps engineer, data scientist will help you with. So you make a post request to that URL with the data and the headers, right? Headers are optional if you don't want to put the header. And you're going to get a response. So whatever response you get, you convert, is going to be in JSON, right? And so to work with that, you're going to have to load it to a dictionary. So what loads does is that you're going to convert a JSON to an object type that Python can understand, most likely a dictionary, right? So it's going to load that, the text. I'm going to select the prediction because I wish I could show us. Let me just search for this. Yeah. 7. Okay. So I just want to like help us understand what's going on. That it's not just magic. API, REST client API. So working on REST. So remember, I told you. Um. Okay. Let me go to the look at this. A classify depending if you have a model that can do classification. There's regress if you have a model that does regression, right? And there's now the predict, right? Where if you want to predict, just it's going to give you predictions, right? In probabilities, most likely. So now the request format, right, is going to be signature, whatever, like this is optional, like you said, like you see here, it's optional. But the important part is instances or inputs, right? So remember we put instances with the images or the going to be a list, right? Yeah. So we send that request to and they gave us examples, right? So if you're working with, I don't want to explain this more, but it has to be in a list, right? For JSON to understand it. If you are Python, if you remember Python, like I hope you are all Python proficient, and we know what a list is, right? So we get a response. The response is almost like a dictionary, but it's JSON. And what is important for us is the prediction here. So that's why we we select the prediction from the dictionary. Remember a dictionary is a key value pair, right? So we select predictions and return it. So we're now going to print out the response we get. Right? So I'm going to run this for us and see what error is, sorry, what response we get. Um, Now we see that we get a connection error. Why? Because The port we are sending to is not available. The port 8501 is not open for any connections. We're using a past URL. Remember, we're using the past Docker image URL to make requests, and so we have to change something, right? It's not open for connection. That's what this error is saying. Failed to establish connection refused. Right. So what do? We now need to make a change. And remember, we port forwarded port 8080 of our local to port 80 of the service running in the Kubernetes cluster. Right. So to make requests to that service or to that cluster now, we have to use port 8080 here because that's the port that is open for connection. So I saved that, right? And we keep the remaining syntax because under the hood is still TensorFlow 7 that's going to find a way to detach and understand this URL, this URLs we're giving it, right? So now I'm going to run that again. Let me clear this up. I'm going to run that again with the change, and let's see what output we get. Okay, now for now we see that we got good requests. We got the request that we wanted, right? True value, predicted value, true value, predicted value. We see that the model is quite accurate and is able to predict the images well for us. So let's call it a day for today. And like I said, practice makes perfect. Anything you don't understand now, the GitHub repo is open. The README is quite readmeable. Like you can really understand that. You can drop questions like pull requests. If you have questions, if you have anything to change, you can make a pull request. And yeah, so by next week, we'll most likely talk about K-Serve and how you can build models with K-Serve. Right. So if there are any questions, I'm open for questions now.
Hi, good afternoon.
All right, good afternoon.
Okay, sorry, I want to ask a side question because I noticed that you are using, I think Linux. Is it Linux?
Yes, Linux.
Okay, and our lessons are also in Linux. So I want to ask, is it that Kubernetes is Linux specific? Because I have a friend that was telling me that if you're using Windows for most of all these, when you have to deploy and all those, it's quite kind of difficult. That the best is to use maybe Linux or a Mac. So I want to be sure if the guy is right.
Um, let's just say Windows, you have to do some extra whatever on Windows, like you're going to search a lot of errors, right? Because I think Kubernetes is built most likely with Linux, like the build the writers of Kubernetes most likely use Linux and Win and Mac to do their tests normally, right? To do their normal tests, and maybe they now test again for Windows. So I'm not saying Windows is not there. I know there are people that deployed Kubernetes clusters with Windows, but you have to do a lot of more work, right, to get it to work there. So that's what I'm saying.
All right, because I know that I've been trying it on my Windows and I've just been encountering maybe one error or the other. I've solved one, I'm encountering another error. It's almost like I want to give up. My second question is not really a question. This what you just finished doing explaining to us. You mentioned something like the GitHub link. Sorry, what's the do we have the link to the repo?
Okay, the link to the repo I'm using. Is that what you're asking for?
Yes, yes, to the codes, that's deployment, the
Okay,
service, the model, and all those ones. Yeah.
okay. I'll share it now. I'll
All
share
right,
it on in the chat now.
all right.
Okay. Right, okay, it's there now. And I also maybe give it to Amoye to share on in the chat for
All right,
others. Maybe those on YouTube. All right. Um, okay, good luck. Take care. Still, there's no other questions. I'll end the call now. Please try to practice, and that's how to grow.
All right, thank you.